Evaluate natural logarithms. Natural logarithm, it has the logarithm form come with the base number e. E is approximately equal to 0.7182. It's a numerical value. And when we go with the base e, we call that is a natural logarithm. When you have a natural logarithm, you will see the ln attached with it. So when you have, let me write down this way, ln e is equal 1. E to the ln is equal 1. It's the same idea. 10 of the log base 10 is equal 1. Log base 10 of 10 is equal 1. Because they cross out. Same way here. So when you have the ln x, that means it has the e here. Okay? So when you have the natural logarithm, natural e, base e, it comes with a ln. When you have the numerical base, it comes with a log. But they are the same logarithmic function. So ln with x equal 1.335. So how do we solve for this one? Let me write down the question here. ln x equal 1.335. Now when you see the ln, you just simply to raise up e to the both sides of the equations. Now e ln you cross out, so your x equal e to the power 1.335. You can input this number into your calculator. So you can type out e to the power 1.335, and then it will give you approximately 3.79, I will say 3.80. 00. We do another one. ln x equal log 5.5. Same way, I'm going to raise up e to the both sides. E ln cross out. So your x is equal e to the degree power log 5.5. Now you use a calculate to input e to the power log 5.5, and then it gives us approximately 2.0967. Graph the logarithmic functions. Property of the graph of f of x equal log base b of x. The logarithmic function, it passes through 1, 0. It passes through b, 1. The y-axis is a vertical asymptote. The domain is 0, infinity. The range is -infinity, to the positive infinity. So all the property here, that looks very similar, right? Because they are all associated with the log exponential function. But the exponential function has the reverse direction. Exponential function passing through 0, 1, passing through 1, b, has a horizontal axis, a vertical asymptote, has a horizontal asymptote. The domain of the exponential function is -infinity to the positive infinity. The range of the exponential function has a 0, infinity. So when we do the graph of the logarithm function, it's a blue line here. Same way here. When your base b is bigger than 1, the tendency of the graph you will locate on the positive x-axis here, which means bigger than is a positive x-axis, right? This is 0. And with all the number toward to the left-hand side, you will have the negative x-axis. So when your base is bigger than 1, your logarithm function will pass into 1, 0. You will pass into b, 1. It's approximate here, b, 1. When your b is a number between 1 and 0, same way, it stay on the right hand side, positive x-axis. Is a going down curve. When your b is bigger than 1, it's a going up curve, increasing curve. And the b between 1 and 0, you will have the going down curve, it's a decreasing curve. Same way here, it will pass into 1, 0. It will pass into b, 1. And the differences between these two curves just because of b value, right? This b is between 1 and 0. This b is bigger than 1. And as here you can see, the logarithm function is inverse with your exponential function. So same way here. Okay, this is a y equal x. When two functions inverse to each other, the function will reflect to each other based on the y equal x. Now we do the two practice from your homework. ln y equal negative 0.37. Find the value without using the calculator. ln 12, this one, we can just simply to cross out ln and let it equal 12. ln e to the power negative 7, same way, you cross out ln e, it's negative 7. ln y is equal to negative 0.37. We raise up e on both sides. Now e ln cross out, so your y is equal to e to the power negative 0.37. We use a calculator to input this value. Or this one, if you cannot use a calculator, then just write down e to the power negative 0.37. Or probably this is a typo. This is not a question under this category. Okay, but this one you have to use a calculator. Graph the function of the log base 1/5 of x. Alright. In order to graph the logarithm function, the easier way to complete the work, we rewrite it into the exponential function. So I'm going to rewrite this as a y, right? So we have log base 1/5 of x equal y. Convert the logarithm function back to the exponential function. Write down your base. Your degree power is y equal x. Now I'm going to structure a table, x and y here. And we start from the y, because y is a degree power. And that's the easier way we can manipulate with the x. So we can let a y equal 0. We can let a y equal 1. And we can let a y equal negative 1. We can go back to solve for x. When y equal 1, x equal 1/5 y. 1/5 to the power y. So when y equal 1, plug in here, we get a 1/5. Right? I have 1/5 to the power 1, so it stays 1/5. Plug in the 0 into the y, we get a 1/5 to the power 0. Any number power 0 is 1. Plug in the negative 1 into the power y, so you will have a 1/5 to the power negative 1. This one is equivalent 5. You just upside down, finding the reciprocal. So now we have this 3 point. Ready? We suppose it should be sufficient for us to sketch the graph. Now your x is here, y is here. Let me write down 1. Okay, so x equal 1/5, y is 1. So you have the dot here. X equal 1, y is 0. It passes into 1, 0. X equal 5, 1 has -1. So 1, 2, 3, 4, 5. X equal 5, y is -1. Alright. So it has a vertical asymptote, right? So the curve will pass into this point, passing to 1, 0, and passing to 5, -1. So this would be the logarithm base 1/5 of the x, the function itself. And this is the way you structure the graph.